So today I'm going to review this thing, the Zoyi ZT-DQ02. This is a handheld LCR meter. Now there's two versions of this. This is the 02, there's also the 01, which is very similar. So that's all the information you need to know. Test frequencies, accuracies, highest accuracies, that's not the best case. And depending on what you're doing, it can actually be up to like 5%, depending on what you're measuring and how you're measuring it. LCR obviously, and Z. And it's got secondary parameters as well, as most LCR meters do. You can go to 10 meg, 10 milliohm to 10 meg, 1 microhenry, 100 henries, 1 picofarad to 100 millifarads. So this was sent to me for free by Zotek. So I've got this at no cost for the purpose of reviews, so to be clear. I haven't been paid apart from receiving this meter. You've got 3 sets of cables. You've got some like multimeter type leads in here. It's literally some multimeter leads, and these have got some sharp points on them. So you've got sharp points like that on them, which are really good little probes. I actually quite like this style. They're really cheap cables, but they actually work quite well. I'll put those sorts of things on like my fluke and things like that. You've got this cable here, which is used for doing battery levels. If you want to measure the internal resistance of a battery, you can actually do it with this version of the meter. So the DQ02 can measure a battery internal resistance and voltage, whereas the 01 can only do LCR functions. So this is a little bit extra for this. Also you get a charging cable as well. User manual, which we'll have a quick flick through. There's a little jumper link thing here, which is actually an insulation jumper. It's not actually a shorting link. Only goes one way as well. It's got a wider slot in that end, so it only goes one way. Apparently you use this if you're trying to do ultra precise measurements with these clip leads instead on the LCR meter function to get you better accuracy. They wouldn't have done this if they thought it was necessary. So the meter itself, on the side here we've got a USB socket there, USB-C, and we've got the standard slots here for plugging components straight in if you already want to, or if you've got a test probe you can plug in. The ones for like the DER 5000 and things like that, they actually fit this. They've got a different connection set up here for these ports. If you just got the plain bar type, maybe you'd be right. Like the DER 5000 one doesn't fit. I tried that. The actual sockets, it's got 3 sockets, it's got 4. So tilting barrel on the back, which to me is a bit flimsy. Like if you're trying to push these buttons, you push them and it sort of just wants to walk away. I mean, this desk doesn't help; it's a bit slippery, right? But I mean, it feels like it's going to want to snap that tilting barrel or push really hard on those. I don't like these. I mean, this is a common, I think it's the similar case that they use on some other equipment as well, or a similar tilting barrel setup, but I just don't like it. It just feels a bit flimsy because it's only these tiny little bits, so I'll be able to hold it together. And also the other lead we get is a proper LCR 4-wire measurement lead here. So you've got the probe lead for like doing 2-wire measurements, and this one's doing 4-wire measurements. And it is actually true 4-wire as well. Each wire goes to each side of the clip. These clips are basic, I suppose. I mean, they appear to be gold plated. Let's see without the brass, not sure. I think they're supposed to be gold plated. They appear to be, but like I said, they could also be brass. They look very similar. But they are at least 4-wire connections, proper ones. Also on the top, we've got this socket on this particular case, because this is the one which does the battery measurement as well. So it's got this extra socket. The DQ01 doesn't have that. I've had to play around with this already, and I've actually used it a little bit and just play with it, just to see how it compares to other things and just familiarise myself with it. Normally I wouldn't do that, but in this case I chose to, just to make a change. So before we get into the interface and actually turn this on using it, we'll have a quick look at the manual. At least it comes with a manual, it's nice. It's in English as well. We're just going to flick through the pages. You can pause it on any page you want to see. I'm not going to read it all out to you. It also does batching as well, so if you want to do like a tolerance and set up a sample to say, right, this is your pass rate, and you can set up a tolerance to that pass level, and you can then filter batches and stuff. You know, you can batch components, things like that, using the LCR functions. It does quite a bit. It's like a lot of other LCR meters. It does the basic LC and I functions. Got the measurement frequencies here, gives you a bit of a guide about which frequency you should be using for different functions, about capacitance values and inductance values, for example, what frequency they recommend you use, which is a good thing to know, so you don't accidentally misuse it. And some recommendations as well for battery internal resistances too. Very handy. Obviously this is typical data. May not be 100% right, but it'll give you an idea. And same thing for different batteries here, different capacities and voltages. So 12 volts down to 2 volt battery, and the capacity of the battery, and what the milliohm reading should be, typically. Again, it's just a guess. You can calibrate this thing as well if you need to do that. Obviously it comes calibrated already, but you need to have all of these resistances and standards for doing calibrations. So you need those resistances if you don't want to do calibration. Also you need a decent voltage source, you want to do voltage calibration, which is part of this one as well. So if you do want to do calibration, make sure you've got all the gear to do it first. And more specs on the back there. These are the specs which you may be caring about, or the tolerances in more detail there about what the actual accuracies are for each particular function and range. Right, let's turn the thing on. So what I think I'll do is we'll do the simpler part of the unit first, and then we'll look at the more complex part of it. So the simpler part is the battery testing. So I'm going to plug this in, whichever way it goes. It'll only go one way. There we go, let's push this on. It's like a locking collar, you just pull it up to release it. Okay, latch is on. In the battery testing mode, it gives you a voltage reading and an internal resistance reading. Now I've got some batteries here which I've pulled out of some equipment which I've actually done a video about. I don't think I've published it yet, but you'll be seeing that soon, I expect, or eventually. So I'm going to get those batteries up here, and we can hook this up to those batteries as well and see what those batteries look like. One is definitely completely knackered, one is probably still okay, and so we'll do those checks, and we'll also do some voltage accuracy tests using the PDVS2 Mini, just to see how accurate the voltages actually are. So here's the two batteries I'm going to look at. As you can see, they've covered in spray foam. That's part of the assembly they're in. Right, let's turn this thing on and we'll start looking at the actual unit, and we'll jump into this, then we'll come back to the unit, I think. This is in the LCR mode right now. Set up for electrolytic capacitors because I was using this and playing around with it and experimenting a little bit. So there's battery test. You can do different speeds. So slow, medium, fast. Obviously it changes the response on the display. This one doesn't have secondary readings in this particular mode. It's got some functions with this. Voltage low, voltage high. I guess it's for internal resistances. So I guess it's probably for the tolerance function. Top is voltage. This is the internal resistance of the battery. So let's hook these up. They say to make sure you connect them the right way around, but I don't think it really matters. Shall we find out? Does it matter? Let's shove. This is the positive terminal this side. That's positive. I'm going to stick it that way. I'm going to stick it on backwards first. There we go. Negative. So it works fine backwards. They say don't do it, but you know. So let's stick it on there. I've got to hold it on because there's not great connections the way I'm clipping on. You can see it's 11.3 volts, so 130 ohms resistance. 130 ohms. Alright, so this battery is really not good. Let's clip onto the other battery. Exactly the same battery, well, exactly the same type, is identical. This is measuring, get a decent connection. This foam is not helping. There you go, 15 milliohms with 13 volts. Significantly better. So this foam battery here is completely dead, and this battery here, they've still got some life in it yet, so I can actually put this into service in something else. I mean, it's old, it's been around for a while, I'm only going to get a limited lifespan out of it, but that told me that I can at least use it for something. It's not completely dead yet.
Bring out your dead! Here's one. 9pence. I'm not dead. What? Nothing. Here's your 9pence. I'm not dead.
So you're probably also thinking, okay, how do I know if this is accurate or not? Because I've just done a measurement. Well, I actually have multiple instruments I can use to check this. Up here is a Agilent milliohm meter, 4338B. I'm going to clip these onto both batteries and I'll tell you what readings I get off this. Once it's booted up, it's just finishing booting. Takes a little while. Alright, let's clip this onto here, clip this onto here. Alright, this one is giving me 127 ohms. Yeah, it's 0.127k, so 127 ohms. And we'll clip on the other one. Again, there's foam which is everywhere is a problem. Get it onto there. Try to get a decent connection. Okay, 15.6 milliohms. So that is only 0.1 milliohm difference to this. So that's actually quite good. And this is a significantly more expensive instrument. Let me show you it. This thing here. Unfortunately, the lights are on it and stuff, you know. Maybe not helping. But, yeah, there's the display. And get this out of the way. Here it is behind there. So, I don't use this very often, but it's like a reference device. So, this is for milliohm measurements. This thing I trust. So over here we've got the PDVS2 Mini turned on, it's now 1 volt, and as you can see on screen we're getting 1 volt out of it. This is with no resistor. Perhaps I'm going to do that as well, I'm going to stick a resistor on it too. You can see if that changes it by much. But the main thing I'm looking at here is how accurate this voltage reading is compared to this. So now the red is because it's got these tolerances on here set up. So the red means it's outside that tolerance, see? And 10 volts. I mean, it's close enough. 2 millivolts out. I think for accuracy, I think that's probably fine. It said like 5 counts and a certain percentage. I can't remember what the percentage was now, but that's actually looking not too bad. I know this is accurate, so the error will be this. Let's hook this up as well to a standard resistor, which is a 100 ohm resistor. I've got several of these, different ones. Let's hook it up to this and see what that does for it, and see how it affects the resistance reading and stuff over here. Now, it may or may not even read resistance. It might read resistance just fine with nothing else. Let's try that first. So resistance, oh, that's up the right one. So resistance only, 100 ohms. Oh, look at that. It's not bad. That's on fast mode. If we go to a slower speed, maybe it'll be better. Yeah, okay, look at that. It's not bad. 100 ohm resistor. It's only a little bit out. Well within spec, I reckon. So here's the first batch of resistors. I've got loads of these things. I've got a range of values. So I've got 1 milliohm, 10 milliohms, 100 milliohms, and 1 ohm right here. I've got the terminals prepared. If you're doing this properly, you do full wire measurement. You actually do individual leads, go into each terminal. I'm just going to use the clip leads because it's going to be good enough for this example. This one first. See if we can see it. So it's 1 milliohm, and yeah, that's absolutely fine. 1 milliohm, that's pretty good. Let's do the next one. So this is 10 milliohms. Yep, that's pretty good. Also, you can do the same sort of thing on the LCR measurement as well for measuring resistance. So 100 milliohms doing 102. Let's check the connections. Maybe it's a slightly dodgy connection there. Still 102. Okay, that was reading slightly high. Let's do 1 ohm. 1 ohm, very good actually. Okay, let's get to the next lot. This one is 10 ohms. So 10 ohms, not bad. How many couple counts out? This is 1k. Okay, 1k is outside of the range. Right, so let's go to the LCR mode then, and we'll look at it here. So we're in auto mode, and we'll set this up to do resistance mode. Let's change the leads to the correct one. Now we're in the LCR mode, we need to use these leads. So we'll do the 10 ohm again, just to compare. 10 ohms, there we go. Slightly different readings on this one. So let's do 1k. 1k, looks pretty good. Very accurate. 10k. Yep, pretty good. And 100k. That one's looking a bit lower. I just untangled his wires again. Yep. That one's reading a bit low, that 100k. I do have a 1 meg ohm somewhere. I'm not sure if it's in here or if it's in the other room. Well, I don't have the 1 meg ohm in here right now, so I'll leave that one for now. Let's actually have a look at the unit properly now we've actually mess with it a little bit. Look at the display and look at the buttons and see what they do. So frequency, you can see the frequency just here. You push that, it'll change that frequency across each of the ones there. So 100 Hz, 120, 1K, 10K, 100 kHz. I tend to use 100 Hz because I always use these sorts of things to measure electrolytic capacitors, and so 100 Hz is a frequency which suits that very well. If you're measuring things like film caps, things like that, maybe you want 1 kHz instead, but for what I do, 100 Hz I found is most suitable. You got level here, which means you can change the level it's testing at, 0.1 through to 0.6 volts. So if you're using this to do in circuit testing, you can set this at 0.1 volts and test the capacitors in circuit and reduce the chance of affecting any neighbouring semiconductors. You've got a bias set here as well if you want to use that. The speed we've already played with, fast, medium, slow. Secondary readings, depends on what mode you're in as well, what you get. But you can do resistance twice if you really feel like it. So let's push this button here. So that's capacitance up here. You've got series and parallel capacitance, you can switch it between us as well. These modes, switching down here, mode is auto, series, parallel. Each time you push it, it jumps around. Inductance mode as well, same deal, the buttons will do the same sort of stuff. Again, secondary functions. Alright, so you want to ping what you're doing. And you've got Z, capacitance again. And there's battery that mode. So auto function means it should actually try and figure out what you're trying to do. And I haven't actually tried to see how accurate that is yet, but it does do that. That not only switches between auto, series, parallel, if you hold it down you've got setup as well. So you hold the buttons down, in some cases they've got second functions. So you hold this down, you can see I'm on version 1.07. English obviously, 100% brightness because I'm trying to do video. It's got a turn off timer, 15 minutes, so if you leave the thing turned on, it'll turn itself off. So you don't drain the battery. And you've got calibration and restoring to factory settings. And obviously a beeper. I always leave the beepers on. I know some people don't like them, but I do. It's confirmation the button press has been seen, that we end up meshing buttons, you know, and potentially wearing things out faster. Obviously that's the mode thing, jumping around between different modes. So you can use this button to get back out of this screen. So you get back out of that with that. And obviously that's that jumping around between different modes again. Electrolytic capacitor. Right? Also option. You got holding and record, so you push hold, it will hold it on screen. There's also a record function which is used with software. So if you have the USB-C connected to your computer, you can use like a logging feature, I think it is, and you can basically record data from this. I think it's not automated, I think you have to push a button to trigger like a save. I'm not completely sure, I haven't used it, and I probably won't either because I think it uses the PC software and I use a Mac, so no. And then we got relative and tolerance. So you can push that. Oh, still got hold on. Alright, relative mode and tolerance. I'll take it out of auto mode. Let's go into capacitance, for example. And then you can see it changes down here. Standard of 10 microfarad and tolerance of 10%. So in this case, if I was moving a 10 microfarad capacitor, it'd give me a 10% tolerance. You can change these as well. So if you want to come down and say, you know, you want to do a different capacitor, you know, you do 110 microfarad or 100 microfarad, for example, and you come back through 10% tolerance, 20% tolerance, right? And then again, push that button to get back out. You've got the same thing for the inductance and stuff as well. So depending which mode you're in, it gives you different options for what that tolerance will do. Right, so in capacitance mode, those are settings to put in. So if it's out of that tolerance, it will indicate red. So if I get a 100 microfarad cap now, that should be good. There you go. 92, so it's within 20% of the 100, so that's fine. And it says pass down there. And also you've still got second functions. It says R instead of ESR, but that's what it means. ESR, okay. And this is on the electrolytic capacitor right now. So yeah, that's that one. I mean, that's what it does. It says out of range, it will show that. So if I try to do the same thing, say a let's get a 220. Yeah, let's get a 220. We'll stick this on it with the same settings, and see it's red because it's way out of whack. So it's expecting 100, and it's not. So if you're doing that kind of batch processing sort of stuff, and you're trying to filter or batch your capacitors or batch componentry so they're all very similar values, you can use it for that. It just makes it a bit more obvious that something's out of tolerance or whatever. It's got its relative mode too. Haven't really played with that yet. It's that one there. So, and also you've got the slots on the front here too. Like those capacitors I had just now. Let's get one back out. Any capacitor will do. Yeah, let's get this one out. This is a 22 microfarad. We can shove this straight in these terminals and read it straight on the screen like that instead of having to use these clip leads, which will be creating extra error. If you want to read it straight in, you can do that. Just plug it straight into terminals. Obviously, polarity still matters. Positive, negative. So that kind of thing you can still do. Now, I haven't charged this up yet. I've been playing with this thing for probably, well, the time I've been doing this video, probably an hour doing a video, and I probably spent half an hour on it last night messing with it. So it's been an hour and a half so far, and it wasn't even fully charged when I got it. And that bar doesn't really like it's dropped down much at all, if anything. I mean, it may not even dropped at all. So I think battery life isn't going to be an issue. And plus it's USB-C, it makes it easier to charge up. And I'm pretty sure it won't take long to charge it to a level where you could use it for another hour, that sort of stuff. Are there any other functions I haven't really tested? I mean, maybe they've got a computer interface, like I said before, but I'm not going to play with that. Let's check capacitor accuracy. You haven't checked the capacitor accuracy or inductor accuracy. Let's do those as well. So over here I've got a 200 picofarad, 1 nanofarad, 20 nanofarad and 1 microfarad standard capacitor. So these are precision capacitors. And we'll hook this up and we'll see what this thinks of these capacitors. It says 208. Now I do have a bias of 0.5 volts on this. Turn the bias off. Let's just change the different capacitance mode. Let's go auto mode. Right. So now in auto mode, 1 kilohertz. Because it's a low value, we can do 1 kilohertz. 202. If you change frequencies, let's just demonstrate that. 10 kilohertz, 204. 1 kilohertz, 218. 100 hertz, 210. Right. So in this case, 1 kilohertz is actually a nice frequency for measuring this capacitor. I think it's like 5% tolerance at these levels because it's quite a low capacitance. So that's that one. Let's try a 1 nanofarad. There we go. Not too bad. Let's try different frequencies again. Back to 100 hertz. Yeah, again 1 kilohertz seems to be suiting it for accuracy, which is interesting. Let's try a different level. Yeah, so the higher level is actually helping it to be more accurate, which is also expected. Right, there we go. It's reading a bit out there. I think it's still in spec. I'm not going to work this out. If you think it's acceptable, great. It's not miles out anyway. Alright, do this one. This is a 20 nanofarad. That's looking kind of okay there. Again, 1 kilohertz is probably a perfectly fine frequency for measuring this. I've got notes on here about frequencies I was using when I was doing testing on it. 100 hertz is looking really good there, actually. So I'll leave it 100 hertz for the next one. 1 microfarad. And that's looking pretty good. In fact, it's looking really good. So that's what you expect. It does have some errors in accuracy in these lower values, but that's kind of par for the course when you've got these smaller capacitors. So lead resistances and lead inductances and capacitances will come into play when you're doing these kinds of small measurements. I haven't done any zeroing or lead resistance calibration on these things. So it says it comes calibrated. I haven't tried calibrating it. So whether doing an open and short calibration on it would help those low values, it probably would. I mean, if I just leave the lead sitting here like this, side by side, be getting, just jumping around between modes. Let's stick it in capacitance mode. We're getting a bit of an error here anyway, right? So we're getting some picofarads floating around here, which will be interfering with the readings a little bit. Okay, so that little bit of lead capacitance and a bit of noise, there's some EMF and all sorts of noise and stuff around the place. That will be affecting these readings slightly. So we've done resistance, we've done capacitance, well, to a point. I could check some large capacitors and actually compare them to another LCR meter. Let's just get a couple of those out. Let's do some. So this, I could get film caps out as well. I could do that. But so this is 100 microfarad. Get my other meter running. So 100 microfarad, reading 91.7 at 100 hertz with a 0.6 volt level. We shall see what this one thinks of it. 92.2, 100 hertz, very close. Right, not much in it, so that's perfectly acceptable. Let's get a much larger value. Let's get a 1000. Let's do this one here. So it's 1000. This is measuring 871 at 100 hertz. What do we get here? 868. 3 microfarads out. And that's not that far off. Within spec, because I think it's like 5% or something. So that looks fine. Let's go even bigger. Let's do a 15. 15,000. So that's reading 13.3 ish. What do you reckon? 13.33? $13.36. Close enough. Yeah, okay, I think that's the biggest one I've got on hand. That seems fine. Let's check inductance. So here we've got a big decade inductor. This can do 1 millihenry up to 10 henries on each decade, alright? So you can actually do like 11 henries in the end. Now, there is some stray inductance and this sort of stuff, so it's not precise, but it's pretty good for gauging how it's responding. So let's change modes. Inductance mode. Let's clip these on. This thing's pretty big, so it's a bit hard to get in shot with the unit at a decent zoom level. So let's do, I'm still at 100 hertz, 1 millihenry. It's not bad. Let's do 5. Not bad. 10 millihenries. Not bad. Let's do 10 on this one. So it's very slightly different. There's a bit of error in this. It's not precise. It's close, but it's not 100% precise. This is a decent unit, but yeah. Let's do 5 or 50. That's not bad. Let's do 100 millihenries. Yep, that's pretty close. Bit more error there, but I think part of that is actually this box, not that. Do 1 Henry. Yep. 5 Henries. Yep. Bit of an error there again. And do 10. 9.93. So I'll do the same on the other unit, my other tester here, and I'll just tell you what they are. So yes, this is a cheaper LCR meter, but I've actually found it to be very accurate, so I've been perfectly happy using this as a comparison source. I do have my DDR 5000 as well, so I can also compare with that. I have a Unity meter as well. I've got a few different LCR meters and they all basically agree with each other, so I'm perfectly happy using this as reference, even though it's a cheaper unit. This is on 1 millihenry, 5, 10, 50, very close, just like the other unit was. 100, slightly down, just like the other unit was. 500, again slightly down, just like the other unit was. 1 Henry, also slightly down. 5 Henries, this one's slightly up. and 10 Henry's also slightly up. So this is where it gets a bit interesting, where there's a discrepancy between the two. This is reading a bit higher, the other one's reading a bit lower. I think we need to do another comparison. So for the sake of completeness, let's do the DR5000 as well. 1 millihenry. Yep. 5. This is a much slower unit, so I prefer to use the bench meter. So you bring it slightly down. 10. Slightly down. 5. Basically right. I think I agree with that. 100 millihenries. Yep, it's basically there. 500. Yep, again slightly down, as was this, as was the other unit. 1 Henry, slightly down. 5 Henrys, down a bit. And 10 Henrys, down a bit. So I was saying my bench LCR meter is a good reference, but now I've got a discrepancy. So, but that's for capacitance. I know I've done capacitance before and they've been fine, so I know that side of it's good. Inductance, since I've played with before, because I've only recently got this thing, so doing the comparison on inductance is interesting because it shows there is a discrepancy after all. But at least this unit here is basically agreeing with this one, or at least very close to it. So I've got 9.936. .93. Oh, you can't see it. There you go. So yeah, they do agree at least. That's promising. So it looks like it's accurate enough. My opinion of this is actually pretty good. It seems to be stable. I haven't any problems with it crashing or anything weird. It's got a good feature set. It seems accurate enough compared to the things I can check. It seems fine. I quite like it. I like the fact it's basically 2 meters in one, where you've got the battery testing as well. I actually have a couple of instruments to do battery testing, and the fact it's got that as well as the LCR means you can actually, you know, potentially save one instrument. And it seems to be accurate enough for that too. It actually works quite well. In fact, I think that actually worked better than the Finersa user I reviewed. Because that had an issue with, you couldn't read resistance unless there was a voltage, or vice versa. I can't remember exactly what it was now. But what you had to have a resistance and a voltage in order to be able to read either one of them, and this will read either, so that's much better. A lot of people don't really use all the full functions of the LCR meters anyway. I mean, most people use them for testing capacitors, and you know, that's basically it. It does a lot. Certainly seems fine. Battery life seems fine. I think that's a good option. I mean, I've got the DR5000. I think that's more expensive than this, and this can do more. And accuracy seems perfectly adequate. The only thing I don't like about it is the tilting stand. This seems a bit flimsy. That may or may not be an issue to you. I think as long as you like support it as you're pushing buttons, like I was, hold it in your hands, you push a button, it doesn't matter. If you're expecting to be able to push a button whilst it's on the bench, I mean, you kind of can, but I mean, you're looking at its tilting barrel. It's not the best. One thing I didn't show you as well, in fact, you can go around these with these cursors and change these with these and still, as well as pushing these buttons across the top here. So you can do it either way around if you want. Yeah. I don't know what else I want to say about it. I don't know. Thanks Zoyi for sending it to me. Would I recommend buying this thing? Yes. I don't know about the DQ01. I'm not quite sure what the price difference was. If you can afford to get the 02, I'd say get that, because battery internal resistance testing is extremely useful because it gives you a really good insight into the health of a battery. If you're not sure if a battery is behaving quite right or not, doing an internal resistance check can tell you a lot, because it tells you how much current it can generate without dying off. Because you can even calculate it. Because once you know the milliohm reading, then you can actually go, okay, milliohms, you know, say 10 milliohms with 12 volts, you know how much current that thing should be able to generate in theory. If it's 100 milliohms, the current's going to be a tenth of that, for example, or worse, you know. So yeah. Anyway, yeah, useful tool. Yes, I think this will go on my recommended list. Yeah, I think the price is pretty good for this unit. So check out the links down below to Zoyi, all that links down there for their product page and stuff. Probably whatever links they gave me will be down in the description, so check those out. Subscribe over there if you're not already subscribed. Other videos to watch down there. Patreon support link over there to help support the channel. Helps me to buy equipment to do testing on and do repairs about. Catch you later.